would miss it, and actually for you, in case you would want to watch it again. So as I already said in the announcement previously, the content of today's session is answer any question you have related to Lab 6. I know that the deadline is Wednesday evening, is it? When is the deadline for Lab 6? Anyone? People, I want you to respond to me. Can you hear me?
That deadline for the Lab 6?
Yeah.
You told us that tomorrow evening.
Tuesday evening, isn't it Wednesday evening? No, Tuesday evening. Okay, so you already had a week and another week and one extra day. I know you had a lot of due dates, other due dates and exams, so I don't mind at all postponing this for you. Remember, the deadline is only to create a structure for you. It's not to be harsh or something. We all need a structure. All right, so any question about Lab 6? Let's do it now. Especially for the, I know you're already asking questions via WhatsApp and email. Would you want to ask any question, or shall I start with Lab 7? I need you to respond, please.
Hello, doctor.
Hello.
Doctor, I want to ask you about part D. I think there's one where the diameter isn't given.
Okay.
For part B, effect of current.
Okay, let me go and show you exactly what you want. All right. Yeah, 1 second. It's opening. I'd rather open it. Yeah, this is it. It should jump to the, yeah. So it's here, right? Okay, so in the part where you have this, the average diameter of the solenoid and the length of the solenoid should, please unmute yourself because I can hear my voice. Please, please, please. Yes, so the diameter and the length are basically the same diameter and length from part 1, because in part 1, you have 2 solenoids of the same average diameter and same length. It's only the number of turns that do vary. I think you have 500 turns and 1000 turns. Now, I believe the number of turns for the effect of current should be given to you. Is this one given to you?
Yes, I think so.
All right.
It's 500.
Okay, so by now you have the diameter, the length, and the number of turns. Are you okay to start part the effect of current?
Yeah.
All right. So I answered your question, Maria. Is that true?
Yes, you did. Thank you.
All right. Any other question related to Lab 6? I think you will do okay in Lab 6. Every time they ask you to compare something, especially if there is a linear relationship, try to prove that it's linear. In this case, I can see compare two plots and both plots are curves. Try to list what's common and what's different, okay? And so you can come up with a conclusion because they want you to conclude. And here they want you to do the slope with the uncertainty and then deduce the number of turns with the uncertainty. Most of everyone in your class, like 99.99% of the class, is expert in this. I can still find a student or two who do not know how to do the rounding or to match the error, and maybe they're a bit not very flexible in the way they do propagation of error, but most of everyone knows how to do this, okay? Compare is the percentage difference. Comment means list the sources of errors. And you can see the lab is not too long, okay? If you remember any question, let me know. I'm gonna start with Lab 7. The due date to submit Lab 7 is gonna be not next Monday, it's gonna be next Wednesday. So you have around 10 days. The reason of the extension is I don't have a proper recording of the experiment and I want to go on Monday and do a nice one for you. I know you don't really need it, but it will be good if you have everything with you, and probably I can take new measurements for you. I don't want to use any old measurements, okay? And then probably you can have a break. But let's discuss the theory today, especially that the theory is basically some optics related material that most probably you studied in grade 9, 8, 10, 11, all right? So probably you know this. Okay, so that's lab 7, optics 1. As you can see, the outline is divided into 4 mini experiments, and this is how the lab report is. Experiment 1 is reflection. You know reflection on a flat mirror from high school, but probably you did not study reflection on a cylindrical mirror unless you did American high school, and I think nobody of you did American high school. So the cylindrical part is something you would cover in the course. For the lab, it's gonna be very introductory. So if you did not cover this part in the course yet, don't worry, probably the lab will be a good introduction before the course. Snell's law, probably you used to call it Descartes' law in high school. It's the law that relates the angle of incidence to the angle of refraction. Most probably you did it in grade 10 or 11. Dispersion is when light goes inside a medium, and thank you, my dear. Okay, thank you, Reem. All right, so dispersion is when light goes into a certain medium and splits into a different colors. Experiment 4, total internal reflection, is when light is in a certain medium and light cannot go out of the medium due to the fact that refraction cannot occur. So I don't know if all these would mean anything to you. Let's tackle each alone, all right, as brief or as detailed as you need me to, okay? Please respond. I need to know that you're listening to me. I do know that you are, but please respond every now and then.
Okay.
All right? Okay, thank you. Now, experiment 1, let me move the chat box away and keep it in such a way to be able to grab a pen. Part 1, reflection. We have a plane mirror, okay? The experiment would look like this. You have all this is a piece of a metallic substance. It has a flat surface and it has 2 curved surfaces. This is flat, this is concave, and this is convex. I'm gonna go back to convex and concave in a moment. You will be given a light source. It will give you white light like any regular lamp. It's not a laser. It will hit the flat surface and will get reflected. This is a zoom in of what's happening. So incident ray, reflected ray, you draw the normal to the surface, which is the perpendicular to the surface. You measure the angle of incidence and the angle of reflection. The law of reflection states if you have a reflecting surface that is plane and very well polished, the angle of incidence is equal to the angle of reflection. So this is the law. Now what do you have to do and this is a quick picture of what's happening in the experiment, although this is a regular mirror and it's not this one because I don't have a picture of this one working on a reflected light. And light, you can see you have white light, regular white light, all right, but you can see a one tiny beam just to make your experiment easier. So question 1, you have a table, you rotate your metallic mirror into different angles. You measure the angle of incidence, you measure the angle of reflection, you do 3 different trials, and you will see that they're actually very close, sometimes equal. What is the relationship between the angle of incidence and reflection? You try to come up with a relationship, but please try to prove it. If they're not equal, you need to prove why they're equal. The difference, is it below 5%? Maybe you can discuss accuracy, I don't know. Are the 3 colored rays reversed left to right by the plane mirror? Francesca, do you have any question before I proceed? You're good, Francesca. All right, so you will see in the video the case where I will do exactly the same experiment, but I will not be using white light. I will use a filter just to show you 3 different colors, and you will see if the reflection happens normally. So are the 3 colored rays reversed left to right by the plane mirror? So try to answer this question. It should not be difficult. That's part 1 of experiment 1. Any question? All right, Francesca. If you guys believe I'm glitching for a reason, let me know so I can turn off my camera, because I have no idea if my internet is good today. So experiment 1, I'm still under experiment 1, but now I'm doing part 2, which is reflection due to cylindrical mirrors. Let me start by showing you what is a cylindrical mirror. This is a part. It's a part of a circle. So if I show you a real picture of your circle, probably you can elongate the circle and find the radius of curvature. So the radius of curvature, by definition, is the radius of the whole circle, part of which is the mirror. So the mirror is only part of the big circle. Okay? Here you have incident rays. The incident rays are actually 5 beams that are parallel to each other. You will see reflection, and this is how reflection is supposed to happen. So this is a concave mirror. Let me grab a pen. Okay, concave mirror, and this is a convex mirror. These are called spherical mirrors or cylindrical mirrors. So both names do exist in the book. So parallel rays will all meet at this point, and this is the focal point, and this is called the focal length. The focal length is this one. You can see it in here. The focal length is F. For the convex mirror, the rays do not meet on the left side of the mirror. You make them meet behind the mirror, and this is where you see F, the focal point of the mirror that is convex mirror. It is believed that F is half the radius. So your job is to measure the radius using this method or any other method that is graphical using a ruler. And your job is to measure F using also the ruler, and eventually to compare if R is twice F. Now, what is the part of the lab report? The focal length, you do it once for the concave, once for the convex, using this method, ray tracing method. The radius of curvature determined using a compass or any other ruler, okay? So basically, the radius of curvature, you measure it for the concave mirror and you measure it for the convex mirror, and then to answer your questions. You guys, I need to leave you for a moment. The kids inside are screaming, I don't like this. Let me talk to them again. I'm gonna keep the recording on because I need to come back in 1 second. Meanwhile, talk in the chat if you need me. 1 second, I'll be back. All right, you guys, I need to tell you something and I'm gonna be very violent. I'm recording the session لحتى على يوتيوب. هلا حدا منكم بيتنفس اليوم ما في ايباد وما في كمان شو من 20 تي في. Understood؟ كل واحد بيقعد لوحده. جيبي اكلاتك وساعدكم. انت مقصصه اوريدي انه there is no doctor system. ولو حدا منكم بيتنفس بيتقصص. ما بديكم تلعبوا، ما بيهمني شو بتعملوا، ما بتتنفسوا. All right, you guys, I'm back. All is good. All right, so they would ask you what is the relationship between the focal length and the radius of curvature. Between the focal length of a cylindrical mirror, there's a word missing, the radius of curvature. Do your results confirm your answer? So you need to come up with a theory that is R is equal to F, and then compare your answers. So probably the radius is not equal to 2F. A percentage difference would help you make sure if the theory and the experiment are somehow accurate or close to each other. What is the radius? Repeat the same thing for a convex mirror. So supposedly the results are given to you. Any question before we move on to experiment 2? So as you can see, reflection is basically descriptive and you don't have a lot of data analysis to do. Basically nothing, just compare your measurements to the theory and observe few diagrams, and that's all. Any question before I proceed? Yes? Please respond. I need to make sure that you guys are listening to me. Okay, thank you, Ramza, for your response. Experiment 2 is Snell's law. You are given a surface of separation between glass and air. This is the surface I'm talking about. Okay, this is the surface of separation between air and glass. This is the surface I'm talking about. This is called an incident ray. This is a refracted ray. This is the angle of incidence. This is the angle of refraction. N1 for air is basically 1. N2 for glass, I think, is unknown. How do you do the experiment? You can see the incident ray. You can draw, let me use a different color. You can draw the incident ray. You can draw the whole piece of glass using a pencil on a paper, and you can see me in the video doing the work. Then you will draw the normal. You can easily measure the angle using a protractor. I suppose you have a protractor. Probably I will do the measurement for you. And you can see only this ray. So you cannot see what's inside. Your job is to remove the piece of glass and to draw or combine this point to this point. Let me zoom in. So everything in red, you can draw it while doing the experiment. What's in blue is inside glass. The only way to do what's in blue is to remove the piece of glass and connect these 2 points together. Okay? Now your job is to measure theta 1 and theta 2. This is theta 1, and the inside is theta 2, not this one. Okay? So now to fill in the table, angle of incidence is theta 1, and this is theta 2. You do it 3 trials. How do you do 3 trials? You simply rotate your prism or piece of glass a bit to change the angle. Then you do N1 sine N1 is equal to, what's that? N1 sine theta 1 is equal, it's here, N2 sine theta 2, and you find N2. N1 is equal to 1 if we believe that what we have outside is air. So N1 for air can be approximated to be equal to 1. And then you repeat to find N2 again and find N2 again. And supposedly you should end up with the same answer or very close answers. You can find the average and the RMS. Find the average. Compare the average with the nominal value. Nominal value is the one given by the manual or the catalog of the equipment. It's 1.5. Probably you will get something very close to 1.5, and they want you to comment. What is the angle of the ray that leaves the trapezoid relative to the ray that enters it? They want you to compare the initial ray to the final ray. Okay, so think about it a bit. By the way, this is not the initial ray, that's the normal. This is the initial ray. Okay, so let me see if I can remove this. Yes. So basically they want you to compare the incident ray to the emerging ray or the one that leaves the trapezoid. Not the incident with the refracted, not the incident again to the refracted. They want you to compare ray initial to ray final. Very easy, think about it. And that's it for experiment 2. Isn't this lab report super easy? You just need the measurements and you can finish it in 20 minutes. Is experiment 2 okay? I need you to respond, please. All right, thank you, Maria. Thank you, Lisa. Thank you, everyone. Experiment 3, dispersion. I want somebody to unmute and I need somebody to speak up about that. How do you explain dispersion? Probably you know it, probably you don't, probably you know part of it. So I'm waiting for someone to explain dispersion. Yes, you can take a moment. Prism or a piece of glass. Chris, would you want to talk a bit about it?
I don't really remember, but I know that the white light has multiple colors. So when we put it on a prism, it releases the many rays of colors it has, and it's called dispersion. We took it in high school, but this is what I remember.
All right, awesome, Chris. You just described dispersion very well. So what Chris said is white light would go into a prism if the edge is sharp for some reason that Chris does not understand yet. The white light splits into many colors. These are not 7 colors. These are infinity of colors. I have white, and then this is the light spectrum, you know. You can see single white ray, and you can see a color spectrum. Anyone has an idea why this happens? You will be asked questions like, what colors do you see? I will definitely post a real picture, not this one, of the experiment or from the video. Probably you would see 1, 2, or 3 colors. I don't think you can see with the naked eye more than 3 colors. So don't tell me you see 7 because you cannot see 7. In what order are they? You can simply tell me the order that you can see. Which color is refracted at the largest angle? This is also be seen in the video. According to Snell's law, here you have to explain. And then you have to turn the wheel. I mean by the wheel, the source initially is white. If you change the source into many colors, and you can see that in the video, probably you can answer question number 8. But before we move to question 7 and 8, I need somebody to speculate. Why do you believe white light turns into many colors? Probably this table will help you. That's a good hint. I need somebody to speak up. Probably pick someone. I'm sure Joe Camel can explain a bit. Joe Camel can explain a bit. Joe Badran as well. Or anybody else. Ramza probably. Rawan.
I can try.
Yes, of course. You can say it wrong,
Okay,
no
so
problem.
I've
Yes.
seen in the table, like each color has different index of refraction. So when they pass through the prism, they will like deviate with different angles. So we'll see each wavelength on its own. So we'll see many colors.
Thank you so much. That was very accurate, actually, Francesca. So Francesca just said, since each color has a different index of refraction, you will end up with different angle of refraction. And that's why initially together, they split a bit with a tiny deviation in the angle. That's why you will be able to see the different colors. All right? N for red is very similar to N for yellow, and they're basically very, very close, you know? But there's a very tiny difference, and this tiny difference will be shown, especially if you have one surface, so refraction 1, another surface, refraction 2. So you have 2 consecutive refractions. This would help for the deviation in the angle to be shown. All right? By the way, all the indices given to you in the problems back in the course are for yellow. So if you go on Google and say, what are the different index of refraction of different media, look very well. They tell you this is only for yellow. So the indices given to you in the problems are basically for yellow and yellow only. But each color will be slightly different, okay? Thank you so much, Francesca. Your job is to explain how the different ends for the different color using Snell's law again will tell you which color will be refracted less or more away from the normal or closer to the normal. Not difficult at all. You just need a real picture in the video. So take a screenshot from the video and try to answer those questions. That's it for experiment 3. Please tell me this is super easy. It's actually very nice. That's why I don't want you to end up with a random video. On LAU YouTube, we have a lot of videos for Optics 1. I wanted to give you one for today, and then I thought, no, let's make a nice video because the experiment itself is much nicer than the lab report. And I thought you deserve to have a very nice view of what's happening. Any question concerning experiment 3? All right, thank you, Chris, for responding, and thank you, everyone else. Now, experiment 4, I'll divide experiment 4 into 2 slides. Total internal reflection is not the most difficult idea, but probably the most critical idea that I'm sure you know, but I don't want you to get confused. Let me start with a general definition of what is a critical angle. I want you to focus on this drawing, all right? Light is passing from water to air, from the medium that is down to the medium that is up. Remember, total internal reflection occurs only when light passes from a more refractive medium like water to a less refractive medium like air. So while light crosses from water to air, total internal reflection may happen. If light crosses from air to water, total internal reflection will never happen. So it has to be from a high refractive medium to a low refractive medium, okay? From a big N to a small n. In this case that I will call case 1, you have regular refraction, incident ray, refracted ray. You will notice that the angle of incidence is smaller than the angle of refraction, to the case that N2 is smaller than N1, all right? So N and sine theta are inversely proportional, so the bigger the N, the smaller the angle, and the opposite is true. So refraction happens away from the normal. As you increase theta 1, you reach a point where you hit theta critical. Theta critical is the angle at which refraction occurs with a 90-degree angle. That's the critical angle. So for angles smaller than theta critical, let's assume theta critical is 43 degrees. This is a simple assumption. I don't know what the theta critical for water is, but we can calculate it and I can show you how. So if theta 1 is less than 43 degrees, I have refraction away from the normal. If theta 1 is equal to 43 degrees, I do have refraction, but the angle is equal to 90 degrees. Okay? For angles theta 1 greater than the 43 degrees, you don't have refraction anymore, and all the ray will go into getting reflected. We call it internal because it stays inside the water, and the refraction because it's a real reflection. Theta 1 is equal to theta 2. We call it total because we always have partial reflection. This is partial reflection. So I always have a tiny 10% of the brightness of the light going into reflection. But here I have a full 100% reflection. And that's why we call it, so this is 100%. That's why we call it total internal reflection. Okay? All right, this shows you the incident ray, yeah, the reflected ray that is always visible, even if it's not 100%. And this is the refracted ray that does 90 degrees with the normal. 90 degrees means theta 1 is equal to theta critical. If you use Snell's law, N1 sine theta 1 is equal to N2 sine theta 2. Theta 2 is 90. And N2 is 1 because we're talking about air, that's medium 2. N is not known, or probably yes, it is known if we're talking about water. Theta critical is the angle of incidence, and you use this equation to find theta critical. Do we know N for water? No. If we assume N for water to be 1.5, so it's not given, I need somebody to grab a calculator and tell me what is theta critical if N is equal to 1.5. I'm gonna wait a bit and I need someone to calculate theta critical for me. Any volunteer? If there's no volunteer, probably I can pick someone. No volunteer. Ramza, can you do the calculation for me? Ramza, hello? Yes.
Yes, just
All right, just grab a calculator, take your time. So theta critical is not known. And let's assume, so this is an assumption, let me write if N is 1.5, what would be theta critical? Meanwhile, I'm gonna save as our file, so you guys can keep it. All right, so I have some answers from Maria, from Rawan. Anyone else? Ramza, are you having any connection issues? Any calculation issues?
Same answer.
Same answer? All right. Are you? I can't hear you, you're glitching.
41.8.
Okay. Are you sure, I'm talking to everyone, that you know how to do that? Please let me know if you cannot do that alone, because for some reason, some students may not know simply how to use a calculator. All right, fine. So the answer is 41.8, right? So 43 was not very accurate from me. I was simply giving an example. All right, now let me go back to the lab. In the lab, this is figure 1. You have a prism. This is air outside, so you have the incident ray. It will go inside, and the refraction happens. And this is where, let me use red, this is where total internal reflection is gonna occur, because I want it to happen inside the glass. I can see refraction and I can see reflection. I want to keep on turning my prism a bit. I think I need to turn my prism counterclockwise until the refraction starts touching the surface. Whenever it touches the surface and starts disappearing, this is where I stop. And this will be my total internal reflection. Okay? If I grab another pen, probably a pencil, this angle, if I draw the normal like that, I can see that this is the angle of incidence and this is the angle of reflection. And they're both equal to theta critical because I still have a very faint refracted ray that is at a 90 degree. So if I have a refracted ray at a 90 degree, theta 1 is equal to theta critical. So this is theta 1 equal to theta critical. This is theta 2 equal to theta 1 due to reflection. It means I have theta critical and theta critical, which means if you measure the whole thing with a protractor, that's 2 theta critical. Okay? Again, remember, you cannot draw experimentally what's happening inside the piece of glass. Your job is, let me pick green. Your job is to draw this, the outcoming ray, and to try to draw this point. You need this point and this point. You draw the whole piece of glass. Let me do the lining in green. And eventually you will remove the glass and you will join this point to this point and this point to this point to be able to see and measure with a protractor to theta critical. So every time you cannot draw what's inside the piece of glass, you simply try to find the points of intersection of the rays, remove the prism, and then draw what's inside. All right? So this is how I just introduced theta critical and showed you the procedure of finding 2 theta critical. Now, what is the lab about? Experiment 4, total internal reflection. Record the critical angle here. Experimentally, you already found 2 theta critical, so you can simply divide by 2. Now calculate exactly what Ramza did in here, and everybody helping Ramza as well. She found the theoretical one. Now you can compare percentage error, command sources of errors. If you believe you're listing the sources of errors over all the mini experiments and they are the same, no need to list them again. So you can say it's the same previous old list, but I would want to add an idea or two depending on the change in procedure. How does the brightness of the internally reflected ray change when the incident ray? So try to watch the video very closely to see the brightness. They're talking, I believe, about the reflected ray. So it's like here it will be more intense because it's totally reflected, and here less intense because it's partially reflected. Is the critical angle greater for LED light or violet light? As you do the experiment, light will split a bit from white into different colors, and you will see one color will disappear before the other. So this would help you discuss this question, which means I'm gonna make sure to have the camera very close to the setup on a tripod for me to do the experiment slowly, and I'm gonna be in a very dark room, hopefully for you to be able to see all the colors well and all the white light very well. All right, that's it for the experiment. I will not share my results, neither the video, before next Monday when I go to campus, and you will be given 2 days to do the lab report until Wednesday. If you believe this is impossible, let me know. So I'm planning to do lab 8 as well next Monday. So it's gonna be today, introduction for lab 7. In a week, in 10 days, on Wednesday, you do the lab report. And then next Monday, we're gonna do lab 8, and I'm gonna definitely give you a week to finish the lab report of lab 8. Lab 7 and lab 8 were originally one lab report, but we split them into 2 because we thought it was a very long lab, even though it's an easy lab. So it's as if we're doing lab 7 and 8 together, split into 2 different lab reports and split into 2 weeks. So the point is not to confuse you. So follow the outline for you to remember the different mini experiments. I still have 3 mini experiments that will be covered in lab 8. Okay, any questions before you are dismissed? Yeah, so again, for the newcomers, a few minutes around 11 a.m. I was telling your friends that very soon we're gonna announce to you what will be done with the midterm. We will do a raise, it will be somehow a percentile, but I'm still waiting for the other sections to do their averages, and when everything will be done, we're gonna share with you your averages and the percentage of the midterm, if it's good or bad, what alternatives we have, and so on and so forth. I know many students are anxious, and I know a lot of students want to know, because you have the right to know. I'm sorry for the delay. It's only that we're looking for what is the best for you, okay? And if you have anything to say, please let me know by email. And for the students who already emailed me, I need you to know that I read all the emails and shared your emails with my colleagues. If for some reason I don't reply, it's only because I don't have any answer yet, but we will definitely look into all your problems, okay? Any comments before I leave you? Yes? I'm still waiting for you to respond. All right, so if you guys are good, you are dismissed. Otherwise, stay behind if you have any comments.